Welcome back, friends, to the LFX online tutorial. My name is Master Japheth, and today we'll be treating stoichiometry. So what is stoichiometry? Well, the word stoichiometry was coined from the word stoichion, and this stoichion means atom, and another word, metron. This metron means measurement. Stoichiometry usually deal with the chemical calculation based on the elementary particles of matter. Such calculations highlight the relationship between the composition or chemical reaction of matters and mole. Well, mole is a unit to describe quantity in elementary particles. There are two major types of stoichiometry. We have the stoichiometry of composition, and also we have the stoichiometry of reaction. Let's discuss some important terms in stoichiometry. Chemical combination. What is chemical combination? Chemical combination refers to the process of two or more substances reacting to form new chemical compounds with distinct properties. There are certain laws that must be obeyed before a chemical combination must occur. And note the key point: new chemical compounds must be formed, and those new chemical compounds must have distinct properties. So let's discuss the law that must be observed before a chemical combination will occur. The first law we'll talk about is the law of conservation of mass. What this law says? This law states that in a chemical reaction, the total mass of the reactant is equal to the total mass of the product. What does that mean? A chemical reaction has formulas and is expressed. Let's say we have a chemical reaction of this state. Here is a chemical reaction. So this law states that this part here is called the reactant, and this part here is called the product. Now the law says that the reactant, the mass of the reactant must be equal to the what? Mass of the product. What does that mean? That if we find the mass of hydrogen chloride, find the mass of sodium hydroxide, find the mass of sodium chloride and water, it's supposed to give us, that is the mass, when we sum the mass here and the mass here, they're supposed to be equal. Let's try that out. So this is what we have: hydrogen to be 1, chlorine, the mass of hydrogen 1 plus chlorine, which is 35. Adding this together will give us 36. So we have sodium to be 23 plus oxygen, which is 16, hydrogen, which is 1, and adding this together will give us 39 plus 1, which is what? 40. So this is 40. So here we have 23 plus chlorine. Recall chlorine is 35. This is the right hand side now, which is the product side. This summation of this will give us 58. So we add this up. Now hydrogen and water, what is this? Hydrogen is 1 times 2 here, which is 2. So we have 2 mass of hydrogen there. Oxygen here is 16. So 2 plus 16 is what? 18. So let's add this up and see whether the left hand side is equal to the right hand side. So if we have 58 plus 18, 58 plus 18 will give us 76. Right? Good. So let's add this up. 36 plus 40 will give us also 76. So this rule is proven to be correct, that the law states that the chemical reaction is correct. That is, the chemical reaction, the mass in the reactant should be equal to the mass in the product. Another law we'll be talking about for chemical combination to occur is the law of definite proportion. What did this law state? The law of definite proportion states that a given compound always contain the same element in the same proportion. The same element in the same proportion by mass. For instance, we have a compound H2O. Understand? It always contains the same element, which is, let's say, H and O, in the same proportion. The proportion of H2O is 2:1. You get that? So this explains why compounds can have the same elements with different proportion, and it will not be another compound entirely. For instance, we have peroxide. Peroxide is H2O2, and it is in the proportion 2:2, which can be written as 1:1. You get that? So a compound always contains, so this is a unique compound on its own, and this is also a unique compound on its own. Why? Because they are having same element with different proportion. So when you identify a compound, the compound will have a unique proportion by mass. Let's see another law. The next law we'll be talking about today is the law of multiple proportion. The law of multiple proportion is the extension of the law of definite proportion. So what does this law state? The law states that when two elements combine to form more than one compound, the masses of one element that combine with the fixed mass of the other are in simple whole number ratio. That is, I know I said the law of multiple proportion is the extension of the law of definite proportion. So for instance, if you have an element also like H2O and H2O, H2O2 and H2O, the law says they are in a simple whole number ratio. Another thing we'll be talking about is the physical combination. So now, what's the physical combination? A physical combination refers to the mixing of substances without a chemical reaction taking place. That is, no new substances is formed, there is little or no consumption of energy, and many more. Let's see a Jamb related question. All pure samples of the same chemical compound contain the same elements in the same proportion by mass. It's a statement of the law of, so this statement, all pure samples of the same chemical. So which statement has this? Which law made this statement? Say, is it multiple proportion? Is it definite proportion, conservation of matter, or simple proportion? Yeah, all pure samples of same chemical compound contain the same element, note, same proportion, definite proportion. Of course, so that is the law of definite proportion. Take this one as it drop your answer in the comment section. An element E forms the following compound with bromine, EbR2, E bromine with subscript 2, E bromine subscript 3, E bromine subscript 4. This observation illustrates the law of conservation of mass, law of definite proportion, law of multiple proportion, law of chemical proportion. Drop your answer in the comment section. Thank you.